Hello, everybody that's joining us from period 3 or beyond. Go ahead and pause this recording after you listen to the directions. We went ahead and took the beginning of class to get down the beginning formulas for law of cosines. In yellow, I was showing what to do to get a side by itself with square roots, or what to do to get an angle by itself with cosine inverse. The really cool thing of cosine inverse is even though we did kind of pause and think about the unit circle, what two angles would give us a cosine of 1/2, we realized that only one of them could actually happen in a triangle. The other one is way too big because, as Ryan Noonan reminded us, all the angles of a triangle have to add up to 180. That is beyond 180 as an angle measure. And so therefore we don't have to worry about an ambiguous case, which is awesome. We're just now starting in on we're solving our first example. We saw we had 3 sides, so the kids were like, hey, use the one that says missing an angle. And I'm trying to show them how to input this into their calculator in the most efficient way possible. But I'm just showing them in their TI grapher something to be wary of, to be careful of, having to do with how you put this in. So one way is to use alpha y equals enter. You see it right here. Alpha y equals enter, the nifty little fraction. Hit the enter sign. It's like A, which is great. I could, anybody remember from last week, how can I make this a decimal if I want it to be a decimal? Math? Okay, you could go down to number 2. I don't know about you, that's a little annoying, but yes, you could. You could definitely do math and then decimal. The other way is alpha y equals, and you could hit this number 4. Either way, fraction to decimal, decimal to fraction, it does it all. Boom, there he is. But here's the dilemma. What about those of you guys that would have done that? Maybe you know to use parentheses, and you would have done 19 squared plus 14 squared. You don't like the alpha y equals, or you've been avoiding it up until this point. Maybe you know the numerator. The question is, what would you have done for the denominator, and why would this be wrong? Those of you that use the division sign, what went so horribly wrong? Ryan Corcoran.
I don't know if this is right, but you note where it says negative 8 squared, if there's a parentheses, the negative doesn't really distribute, so we could subtract 1. So the value can change that.
It's actually not a negative, it is a minus because it's in between 2 number values. And so this truly is saying the exact same thing as that. And it will, that subtraction, which is adding a negative, that will only go with, my calculator knows PEMDAS. It's going to add, actually it's going to square, square, square. Then it's going to add, then it's going to subtract. It has PEMDAS programmed into it. So it's actually, this is safe. But what's not safe? Natalie?
Isn't the numerator, like the cosine negative 1, like only going to the numerator? Like, don't you have to show that, like, don't you have to put parentheses around the denominator too?
Good. What you first said, I think, was, isn't the cosine, using a couple of my tricks, like second back goes to the front of the line, second insert or delete. I think Ryan Noonan asked me that last week, and just pops it without deleting stuff. I think what you first said, kid, was, doesn't the cosine inverse need the whole thing? I mean, I could put parentheses around the whole thing, which I will need when I do cosine inverse. However, that wasn't necessarily the problem yet because I haven't done cosine inverse. But you got it right at the end because you said, doesn't the denominator also need? And the answer is yes. I need all 3 of these. 2 times 19 times 14. I need all of these in the denominator. And right now, my calculator doing PEMDAS without the parentheses said, oh, cool, you want me to divide by 2. And then multiply that whole thing by 19, then multiply that whole thing by 14. That made it way too big. But if I say no, parentheses, parentheses, then divide. Now I'm good. My people that use the division sign, that's the only possible way to do this. Like, you need to have your numerators and denominators in those parentheses. But if I were you, I would just use alpha y equals. That way I have the whole shebang without all these crazy parentheses in my cosine inverse for me to, hold on, pause. Yeah, I'm in degree mode, go. Dun, 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 dun. Did you guys get 22.075?
Yeah.
How are we doing? We okay?
Yes, sir.
Questions?
How
Right.
do you know whether to have it in degree mode or reading?
It it has to be based on the question itself. So this one didn't specifically tell you. So WebAssign would have either said something, I think like in the back of the book technically for this one, it says it gives the degrees or the radians. If it was like a textbook question, and in WebAssign, they're either gonna have to say explicitly in the directions, or have like an or and you put both of them. Just keep an eye out if it has a degree mark. Is that cool? If it has a degree mark, then we have the right answer. If it doesn't have a degree mark, we need to go change that mode. 22. And you, I mean, you guys have experience. You did 6.1, right? So were they telling you degree, or were they giving you degree marks, or?
Yeah, thank you.
Okay, because you guys should have had at least a few side ones, right? Okay. And they gave you, what was it, the word or the degree mark?
Degree mark.
Okay, so degree mark is your indicator to know to have degree mode. Good, good, good. Okay, calculator questions. Some of you are maybe doing this on the calculator for the first time. Baron.
I just wonder why my calculator shows me that it's anti-fun.
Are you using the fraction feature? And you have the plus and the minus? Or if you're doing division, are you sure that you had all of this in parentheses? And you're in degree mode? I'll come see. Ryan Krikorian, what else?
I was gonna say, when they just give you all the sides and no angles,
I wish you had your
right?
Say it one more time.
So when they give you all the sides but no angles, that's when you use the cosine formulas, right?
Yeah, that would be pretty strategic.
Okay,
That'd be pretty strategic. Or if you use the initial one, the a squared equals b squared plus c squared minus 2bc cosine a. You could use that one, Ryan, but you would know the a squared, because it would have been 8 squared equals. You could have used this formula right here, but it would have been 8 squared equals, what are my two numbers, 14 and 19? You would have had to have subtracted, divided, and then cosine inverse, which is the exact same thing. So you could have gotten there from either one, but using the cosine formula is just a little bit faster. As I try to figure out Barron's calculator that he is using instead of his TI. Remember, Barron, you have to use your TI for the test. Ready, set, go. Ready, set, go. Johnny, go ahead. What's up, buddy?
I had a calculator question.
It's not 8 on the denominator. It's over easy. You did. You did one. Yeah.
I don't have.
I don't like when they do the degree and the inches. Like, you don't want to like three
Maybe we use this one, Johnny, and then another one. Because I actually can't.
Yeah.
No, there's more. For you want to find the side C first, and then solve for angle A and C after. I know, but it's because there's like more now.
Johnny, this will reset your RAM, you okay?
Yeah. Well, I just reset it. I'll have to go through the.
Thinking of it.
Yeah.
How do you just
Because you have to use this formula.
That's whenever it finishes.
So
Yeah.
we probably want to use the standard form because we're trying to find side B.
Yes, I totally agree.
So we should use like the b squared equals a squared plus c squared minus 2a cosine.
How you guys doing? You agree?
Yes.
Right? Is that the one that you used?
Yes.
Hopefully taking the square root of both sides to be all nice and efficient, right? Then I can go ahead and throw in everything I know. Like, I don't know you. That's okay. I don't need to. I need to know everything else. 6.2 squared plus 9.5 squared minus 2 times 6.2. 9.5 cosine of. Question, why am I making it 75 and 1/3?
Because 20,
It's like 20 60ths. Yeah, does that make sense?
Yeah.
And he's like, it's like 20 minutes. Exactly, which is 1/3 of an hour. And I'm being lazy. But those of you guys that found it last time, where could you find the minute mark?
In second angle.
Second angle, second apse, right? Takes you to angle, you can find the degree, you can find the minute and do it that way. I'm just being a lazy bum. Why is the square root there? Because I'm being efficient. And I'm just going to go straight for B. So I'm going to go ahead and throw in that second square root. I'm going to throw in my 6.2 squared. P.S. My calculator knows PEMDAS. It's going to do the squared when it's supposed to. It doesn't need parentheses. There's no like distribution or anything crazy happening. Plus 9.5 squared minus 2 times 6.2 times 9.5. Cosine of, make sure they're all next to each other. If you want to put in times, you can, but my calculator understands parentheses. 75 and 1/3, because I'm lazy. And I'm done. Dun, 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 9.940. No, 9.943.
What'd you put for cosine 75?
I did the 75 plus 1/3 because that's how I get my mixed number 75 and 1/3.
So how did you write it in the calculator? It was 75.
Yeah, how did you put the 1/3?
Oops, wrong one.
Really struggling with that.
I got you. I do this and then,
Plus,
but I'm being a bum. You can go use your minute mark. Just have to use your degree mark and then your minute
I
mark
just
and then,
didn't get how you put the 1/3.
yeah.
Okay, that's what I got.
Wait. How'd you get that?
Are you in degree mode? You are, right?
Yeah. I got it.
And it's all under a square root.
What'd you get?
I got 10.1.
Probably added something.
Yeah. Double check you didn't put like the wrong decimal somewhere. It's so easy to mess something up. 6.2 squared plus 9.5 squared minus 2 times 6.2 times 9.5.
Okay.
Oh my gosh, I got 9.
What?
Square root? Oh, I did. Now it's the root.
So do we have
Honesty.
Yeah, I know.
Oh, I didn't finish. 9.943. 9.943. Oh, but guys, hold on.
Never done.
Question, what does this one ask me for that the other one didn't? It says solve the what? Solve the entire triangle.
Find the angle.
Now wait,
Oh
I want us all to be getting the exact same answer, which means no rounding. What? No rounding. What do I need to go after next? Or what's something I could go after next? Someone help. What am I missing?
Use the cosine.
I heard A. All right, so let's go after cosine A, right?
Yes.
Okay, so can I say cosine A is equal to, what do I need? I need B squared. Remember, it's the Pythagorean, everything else, take away whoever you have, and then 2 times the other 2. Got it. I can take cosine inverse of both sides, right? But question, what am I going to have to use that I just got some pretty nasty decimals for? I know I rounded it, but I want us all getting the exact same answer with no rounding error. Who's going to be messy? B, right? So pause. Do you all have 9.943, etc., on your calculators? Ready? Do you want to copy paste it, or do you want to stow it as a B? It's up to you.
Oh my gosh, do it again.
Do you want to stow it as a B, or do you want to copy paste it? Stow it as a B just means you have that answer. Hit the arrows. Stow it. Store it away. Store it, right? Stow it as an alpha B. And then what can you do? Ready? Be efficient with your resources. Second, cosine alpha y equals enter. How we doing?
How does it get it to be B?
You gotta take your number and then hit the stow button. And it says, I'll take him, and then I had to type alpha B. If you need to, go copy paste your square root and do it again and hit enter.
No, I have the 9 point.
Ooh, nice. And then hit your little stow. Has a little arrow.
Yeah, I did that.
And then do alpha B. Alpha apps. You see it?
Yeah, but it's not doing anything.
B squared.
Come on.
Oh. You're trying to copy paste. Sorry. I was like, you could copy paste it if you want. Or you could stow. It's like the next one.
Oh. Okay, cool.
B squared plus. We should all get the exact same answer. We should, hold on. Who's C? He's 9.5, wrong one. I'm going after A, right? 9.5 squared minus 6.2 squared all over 2B C.
Oh my gosh, I clicked enter and it was there.
Double check all your parentheses. Double check you got everybody in there. Woo! 37.102.
Yeah.
We should all get the exact same answer. If not, stop and ask questions. B squared plus C squared, that's the 9.5 guy. Minus A squared, that's the 6.2 guy.
Is that 2B?
2BC.
How do I get B into the thing?
Oh, you just said it. He's the green one. Like the F1. There you go.
Oh, there we go.
There you go. Yeah, Michelle.
I just don't know how to write this.
Ah.
No, it changed. It literally changed. I don't know why. But I didn't like because you divide that by 2.
So then you see.
What's the denominator?
I think we're actually.
Wait, Miss G, we don't have to do cosine C, right?
Bro, Stonefire after the game.
Yeah.
Say it one more time, Andy.
We could just do like 180 minus.
Oh yeah, I don't have to do another cosine formula. Hold on, Andy has a good point, but let me get my answer, guys. Help me. It was 102
Yes, sir.
because it was 101 point or 1019 something. Okay, hold on. Andy's like, wait, we don't have to do another one, right? Because 3 angles of a triangle. What were you saying, Andy?
180 degrees.
Ah. So can't I just go ahead and say angle? What am I missing? C
Yes.
is equal to 180 minus what?
Minus 75 and 130.
Right? Exactly. Can't I just go ahead and say, take my 180, subtract. Can't you go steal, copy, paste, right? You guys getting your copy, paste? Go up, hit enter. Plus, and then as Andy said, I'm doing my 75 and a third, but once again, I'm lazy. You can go get your minutes and seconds. Final answer, we should all be getting the exact same 67.565. 67.565. We should be getting the exact same.
Yeah, so I thought I was solving C, and I took it as 75, so another wrong. So we're solving
But just make sure you have all the decimals the same way I am, so that you're rounding and technically off.
Oh,
That's fine.
67.56.
565. 56474 186 to be specific.
565.
Careful, if you start rounding early, if you don't keep all the decimals, you are not going to always be getting the same answers as me, and that's dangerous for a test. 67.565. I'm not kidding when I'm saying we should be getting the exact same answers, and I don't just mean close. 565 degrees. Whoa. I have A, I have B, I have C, I have A, I have B, I have C.
You go back to your practice.
Yeah, I can.
You got 67.
Yeah, I did.
Why did you get 66?
Wait, what?
I did 75 and a third, and this guy, 37.
Yeah, and then you got 67.
Yes, that's angle C.
So then why did you?
Oh, I don't know why I did that. Because I was talking to Ryan and I got distracted. Whoa, 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 whoa. I know.
What did I miss? What happened to me?
It was all me. But see, imagine if you hadn't asked. You would have been so lost. 67.565. All right. Ready, set. Let's get ready for softball. Just kidding, not yet. No. Keep your seasons going, but let's do the word problem. The pitcher's mound on a women's softball field is 43 feet from home plate. The distance between the bases is 60 feet, as is shown. The pitcher's mound is not halfway between home plate and second base. How far is the pitcher's mound from first base? What are we going to do, guys? Find H. Nice. The question is, all right, calm thyself, little munchkins. Adults in training. Find H. Can you apply the law of cosines if A, B, and C are not there? Can you apply the law of cosines if A, B, and C are not there? How do the formulas work? Is it going to be a cosine of equals, or is it going to be a side squared equals? What am I doing? Hey, show me you can apply law of cosines if A, B, and C, those letters are missing. I have H and F and P. Why? First, pitchers, home, I don't know what the letters are for, but anyway. A, B, and C? I don't have A, B, and C. Can you do them with the other letters? I'm coming, Lucas. Is it going to be cosine, capital H equals, or is it going to be little h squared equals? What am I doing? Little h squared equals. Question, do you know to take the other two sides, even if the A, B, and C are not there? Do you know to do minus 2 times those other two sides? Do you know to make the formula, I should say, the angle match the side? Oh, pause. Do you know how to apply the law of cosine? Look and check. We'll see if you guys can get it right before I get there.
What?
You have all the sides, right?
So we
So,
go
what are we
H
trying to find?
squared.
Assignment.
Find the base?
Because the test isn't there, right? Out
All
of
the sides.
Oh,
How
dang it.
far is the pitcher's mound?
Oh, I haven't solved it yet. There you go. It's coming, Paul. Let's check.
That's what I said.
Are you writing it? I got to say what? Right?
Bless you. P.S. Great time for us all to double check our masks and make sure they're up. Cosine of 45 degrees. Hey, we could put in 2 root 2 if you want to be super snazzy and show off your unit circle knowledge. 42.430. How we doing?
Good.
Same exact decimals, or are you just like 42's close enough? Better be.
Oh, I deleted it.
Better be. 42.43. Just don't forget that. You guys need to be square rooting both sides if you forgot that. H is equal to 42. Natalie, keep me honest. What was it?
42.43.
0, right?
Yeah.
Cool. And that is B. So question. We're going to go to area formulas in just a second, but this is what I want to talk about right now. Before the area formulas, which are fun and easy and pretty straightforward. What if I was to give you this? And I said to try to use the law of cosines for, no, it's an ambiguous case. I know, let's try. Let's try. Nice thing is I have A's and B's and C's. Question. Why am I putting this here even though I don't know C?
You can still solve for C.
Because I have an equation with how many unknowns? Just one. Now, it's in 2 different places, which is kind of annoying, but I do have one equation, one unknown. That's like algebra basics. You just solve, right? But wait, why didn't I put the C over here?
Because you don't know have angle C.
Did you learn your law of cosines? Whatever you have here, you also need it matching over there. Your little C squared needs to have a cosine of C, or your cosine of C is going to have a C squared. I have to somehow make a formula with both. And I need these guys to be bookended. Just kind of getting you familiar with the formula. I can't go making up a new variation. I need whatever angle I have to match whatever side I'm using. So here's the question. Can I solve for C using this formula? For you guys to be pondering, can I solve a C using this formula? No, what's that? Party pooper. Just kidding, just kidding, just kidding. Don't get lost, come on back when you're ready. C squared minus, what do I have, 62? Now, question. Why am I writing this so weird?
Because you factor that way you can have the answer.
It's a quadratic?
No.
Disgusting.
Why do you have to bring other things we've already
Is it a... You're welcome, I'm a math teacher, it all builds. Alright, come on back. When you learn a new skill, you have to remember the old skills too. Question. How do I solve a quadratic? Yeah. If you say factoring, I'm like, do you really want to? No, we don't know how to factor, no. But I do know the quadratic formula, and the quadratic formula says C equals negative B. Remember, trying to be efficient with our resources and not have super nasty decimals everywhere. C equals negative B, a negative, there he is. Plus or minus square root. B squared. Hold on. Watch my notation. Minus 4AC all over 2A. Watch what I wrote. Why did I put the parentheses where I put the parentheses? Did I follow the formula? Am I being very precise?
Just use that as C.
Go ahead, Sasha. What's up, kid?
The C in front of cosine, why did we add that?
I didn't add it per se, as much as just follow my formula. I knew I had to use the only angle I was given to help me out, which means I was stuck with this formula, and this formula is bound to have this orientation of variables. So I had to have my c squared, that's unknown. I had to have my 2b. I don't know you. But what I did is I rearranged. That 62 with the cosine blah is my coefficient for my c.
Okay.
Does that make sense? Ryan.
How did the cosine 2, where did the cosine 2 come from?
You mean cosine 20.5?
No, like in the second line.
The cosine 20.5?
Yeah, what's to the left now?
Oh, 2 times 31 is 62.
Oh, I just read it.
Yeah, I saw this as a coefficient.
How did you do that?
Well, because I'm used to seeing them as numbers. For you guys, you're pondering it right now. Like, you're being exposed to it right now. But isn't cosine 20.5 just a number? Right? So then 2 times 31 times, like, multiplication can be switched. It's called the commutative property. Well, I did because I needed to see what is A, what is B, what is C, which, okay, it's quadratic, but I needed to think about my ax squared plus bx plus c. I had to kind of get that for my quadratic formula. You see it? Only then could I see what to put in my quadratic formula. As far as negative b, which was negative blah, plus or minus squared root b squared blah squared minus 4 is equal over 2n. Andy, was that you with a question, bud?
Yeah. I'm just a little bit confused on, like, so you're doing the quadratic formula, right?
Mm-hmm.
So how did you get the c squared and the c over to one side? Like, on the other side.
Oh, I subtracted 12 squared.
Yeah.
And I lined him up. He's not a like term, not a like term. He has a c, but he is a like term with a number.
So, no, but like on the bottom formula, how'd you get that c by itself? Because there's a c squared and a c.
Oh, remember, I'm using my basic quadratic, which is a little annoying because it has a's, b's, and c's. And so does my triangle. But in general, remember, I have my x equals my variable for an a. Okay, shh. I know. Question is, can you plug it into your calculator now, my munchkins? X equals negative b plus or minus square root b squared minus 4ac over 2a. The unknown. The zeros of the unknown. The quadratic formula solves for the zeros of the unknown variable with this orientation, which is just completing the square simplified. My unknown, though, wasn't x. My unknown was c. And mine wasn't like a clear a, b, c, but I did say what number is in front of the squared variable, a 1. What number or coefficient expression is in front of my other variable? Well, this mess, which is my b. And then what is in my constant spot? Well, that mess, which is c. And so I plugged in my x equals, well, c equals negative b. A negative is a positive. Plus or minus square root b squared minus 4ac all over 2. And I was lazy and didn't write it because 2 times 1 is 2, but 2a. Boop, boop.
How did you have the 8?
Understood 1. If I have 1 there, you know what I mean?
Yeah.
If I have 1 there. So I'm going to go ahead and throw this into my alpha y equals. Why? Because I'm being efficient with my resources and plugging and chugging once. Plus or minus. Can I do that? No, but I can do a plus and then do a minus the next second. That would be so sad I would have typed that in wrong. 62 cosine of, what was it, 20.5? Careful, that whole thing needs to be squared. A negative squared will be a positive. It's not a big deal. Uh-oh. Cosine and the cosine and the negative 62. Ooh. How'd he get outside? You're not supposed to be outside. Get back in here. You're supposed to be under here. 20.5. There we go. Squared. Minus 4ac. I mean, I can put it all in. It's times 1, but...
Why is it? I thought A equals 12 though.
And that's the dilemma, right? Because A, B, and C of a quadratic formula is different than A, B, C of a triangle. So if you want, like, I could totally change my variables for the quadratic formula to be something else. A, B, C, so I guess this could be D, E, F, but E is a letter in math, so G, F, G, H, F, G, H. So I could say fx squared plus gx plus h. That way it's not the same variable. So x equals negative g plus or minus square root g squared minus 4 fh all over 2 f. If you don't want them to be the same letters, I could change it. It's just kind of nasty. But remember, I'm trying to just solve my quadratic. I am not looking up here at ABC. I'm just trying to solve my quadratic. Plus or minus square root b squared minus 4a. So a is just the leading coefficient here. So f, h, 31 squared minus 12 squared.
Why don't you do that? So much easier.
All over 2a, 2f. The one thing I'm a little dicey about is this big subtraction in the middle, but PEMDAS is going to do parentheses and then multiply, multiply, then subtract. I think I got it. Wait, what about the minus? Well, the minus, I could do second back. I could just go make a minus. But guys, which one's going to make a better side of a triangle? Oh, struggle bus. The only side of a triangle that I wouldn't have... whisper. The only side of a triangle that I wouldn't have kept would have been a negative one. But guys, are either of these negative?
No.
If neither of them are negative, how many possible triangles do I have? I have C and C prime. I have two different options, which is exactly what the law of sines would have done. But question, here's what I was trying to prove to you. Because these are both positive numbers, the plus and the minus of the nasty square root, I have just seen that there are two different ways to put this information together. I could either have C or C prime. So if I was supposed to solve the entire triangle, I would have to go forward knowing that there are two different options, right? Does law of cosines work? Yes. Plus or minus square root got me two different possible sides. But here's the question that I want you guys to consider. Does it work? Yes. Law of cosines is great whenever I have more sides than angles. The only dilemma is the ambiguous case. The question is, what would you rather have done? Would you rather have done all of this and you have to keep going, or would you have rather have done this? Oh, I'm just going back to section 6.1 for a second. What would you rather? This math or that math? Okay, but what do you have to remember when you do this math?
You have two answers.
You might have two answers, but how do you find two answers? Because when you solve, aren't you going to get b is equal to sine inverse of 31 sine of 20.5 all over 12?
Yes.
Law of cosines, you get a plus or minus, so you know that you should be looking for 2. Law of sines, you don't have a plus or minus. How do you know to look, or what should you do to look for the other option?
Subtract it by 180.
But that's something that you have to remember. Yes, I agree. This math is easier if you know what you're supposed to check for. And that's back to section 6.1. And now is almost a perfect time for us to go peek at that web assignment. But once again, both of them are options. P.S. Right now, I have still not even solved for angle B. If I wanted to solve for angle B, my next step with law of cosines would be like, okay, now you have all your sides. So now let's do cosine of B is equal to, establish him as a C. Cosine of B is equal to a squared plus c squared minus b squared all over 2ac. You could take cosine inverse of both sides, but you would have to steal this and do it one way for one, and do it the other way for the other. But that would only be for C, then you'd have to do it again for C prime, and that would get angle B's two options, and then I think you would still have to go find angle C, but you could do that with the 180 trick that Andy already said. There are two different ways to solve the ambiguous case. The question is, would you rather use the quadratic formula, or would you rather just remember sine inverse and 180 minus sine inverse? I think the ambiguous case is still better with law of sines. But I'm warning you that your brain, once you get used to law of cosines, will want to use law of cosines because you're like, it has more sides. I still think it's easier as long as you remember what to check for. As long as you remember what to check for. Guys, we did keep on going as far as the one other case that you could see was solving a triangle with law of cosines. However, there's also one last formula I want you guys to see as far as how to find area. And that might bring us to a different question as well, because I believe that we never talked about area with law of sines. Both law of sines and law of cosines gives us a way to solve for area. And this might be where you got a little stuck in web assign. Right? Something about area, right? So here we go. There are two different ways to solve for area. Wait a minute, hold on, geometry. There are three different ways to solve for area. However, right now I feel like I am battling you every second of every moment of trying to give you any sort of content or any sort of explanations. I just need the extra conversations to calm down. If you don't mean to be battling me, then hear me cry for quieter environment in our classroom, okay? I know as a student you don't really think it's that big a deal, but if you were up here trying to teach, it's really hard, really distracting, and some of your classmates need to be able to hear, okay? Thank you guys. But thank you also for troubleshooting and helping each other. But we do need to get one last little bit of content for both of these sections, and it's called area. In geometry, you might be like, what's the big deal? In geometry, area equals 1/2 base times height. Right? Of a triangle? Or over here, area equals. So question, why am I showing you other area formulas? What's that name for a triangle that's not a right triangle? Oblique. What's the dilemma with any oblique triangle and the area formula? What do you not have? I don't have a right angle, and since I don't have a right angle, what else don't I have? Does anybody remember that the height is the same thing as the altitude, and the altitude is the same thing as the vertical distance straight up? And that vertical distance straight up is at a 90-degree angle from the ground, if you want to think about it that way. 52 is not the height of the triangle. 52 is the slant height to the actual altitude, which is outside and missing. The dilemma with any oblique triangle is I don't have my altitude. I'm missing my height. I'm missing my altitude because I do not have a right angle. At least I don't necessarily have a right angle. I'm not sure if I do or not. I might not. So the same dilemma as with either one. If you have these weird triangles, guys, you might not have the height. You probably don't have the height. The height is probably either within the triangle or it's outside the triangle. I'm not sure what the height is. So it's not that geometry fails, I just don't have the nice easy information. So law of sine says, okay, here's a way around it. Law of sine says, here's a way around it, and it has to do with a sine. This is only in the law of sines formula because it has a sine in it. That's the only reason it's here. And this one's only in the law of cosines formula because it has lots of sides. And lots of sides is what law of cosines is really, really nice for, having all the sides. If I was to, and you don't need to do this every time, but if I was to take some general oblique obtuse triangle, make it super obvious. Super obvious, super awkward, definitely not a right triangle. If I was to draw this guy and say, hey, there's the height, look, I got him. And if I was to take all of my other sides, which could be like that triangle, so A and B and C. So here's my little A, here's my little B, here's my little C. B is the hypotenuse. B is the hypotenuse to this little right triangle. So if I wanted to find this little guy, I would need to think about whatever this angle is, which I could think of as 180 minus, who's this guy? Angle C. I could think about this little guy as 180 minus C because C is the little guy that's on the inside. So to make things a little clearer, let me put the C on the inside of the triangle. I'd have to do 180 minus C to get that guy, and then I could think of sine of 180 minus C is equal to H over B. But what we just talked about a little bit ago in reviewing the ambiguous case is that sine of 180 minus C is the same thing as sine of C. I can actually use that cool property of the unit circle just to say this is true. Then I can say H is equal to B sine of C. And now all of a sudden I can say, okay, look. Whoop, 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 whoop. Oh no. Yeah, that's true. But in this one, my base wouldn't have been B. My base would have been A. Because that's the bottom of my triangle. And so if I wanted to find the area, given what I had, it would be 1/2 A times B times sine of C. Hey, look, 1/2 A times B times sine of C. It's a thing. Now, to avoid all of this geometry every single time, here's another way of looking at it. Given, to avoid all that geometry, given side angle side, given side angle side of an oblique triangle, a non-right triangle, I can simplify the geometry that would always lead to these formulas by just memorizing these formulas for area that say 1/2 side 1 times side 2 times sine of your angle. 1/2 side 1 side 2 times sine of your angle. Given side angle side. I don't mean that as an A as an angle A. I mean that as whatever angle you are given. Therefore, I can find this without drawing crazy geometry and hypotenuses and using 180 minus to fill in the exterior angle. I can just say, oh, hey, I have side angle side. I'm going to have 1/2 52 times 90 times sine of 102. The geometry gets you there. You can also just memorize the formula and not need to worry about the geometry, which is a little bit, I wouldn't say convoluted, but tricky. A little bit tricky. I wouldn't say convoluted, but I would say a little bit tricky. So just to practice our fancy skills with our calculator, this wouldn't be a big deal to plug in, right? Because you would just do 1/2 times 52 times 90. No crazy fractions. It's in the law of sines section because it uses a sine. That's the only snazziness about it. And my final answer would be 1/2 52 times 90, my two sides, times sine of my included angle. And here he is. Boop. The only thing to remember then is just that area always has units what? Squared. So it's going to be meters squared, and I am done. If I have side angle side, I'm going to use the area formula with a sine. Why? Because if you drew it, that's what you would need. It's a little tedious to draw it though, so why not just memorize the new formulas? That's how the sine helps me find areas of obliques. Cosine, well, actually, cosine isn't even in his formulas, but once again, cosine is really, really nice whenever I'm given lots of sides. I like lots of sides. Lots of sides, like 3 sides, give me an angle. I can do it if I have lots of sides. Now here's the awkward part. Side angle side is actually more of a law of cosines type of thing, but law of sines is better with side angle side as far as just use a sign for the formula. It's a little awkward why they put it in the other section, but I get it. It has a sign in it. They want to use it. Okay, fine. Law of cosine says, I like lots of sides, so let me show you how to do a formula with lots of sides. If I was to do like a is 43, and B is 53, and C is 72. That could be a mess to do the geometry. That could be just gross. So what's easier? You don't even have an angle, and I don't want to go find an angle. If I did, okay, fine, I could use the other area formula. But I don't want to find an angle. Isn't there a formula I can just plug in and the answer is yes. This guy's great if you have side, side, side. But be careful. It's not just one formula, it's 2. I need the semi-perimeter, which is A plus B plus C over 2. I need that semi-perimeter, and I need it plugged in. But once I have my 3 different side lengths, well, I can do a few different things. One thing is you can just do something like 1/2 of, add them all up, so 72 plus 53 plus 43. And can't we do that little, like, stow it away as an S? If you want. You don't have to. But you can. You can store it away as an S. Or, I mean, 84 is not this horrible number to plug in, right? Like, I could just type 84. It's not a big deal. And 84 minus my first side, whoever he is. The order doesn't matter as long as you get them all in there. 84 minus, I'm just showing you it wasn't that big a deal. But if the semi-perimeter was nasty, yeah, you could do that S. It's not a big deal either. S times S minus one side times S minus another side. And it's basically doing all of our geometry for us in a much, much, much quicker way. If you guys want a challenge, I guess you could do the geometry every time, but whoops. Second, delete, insert. There we go. Sorry, my bad, my bad. Oh my goodness. There we go. And once again, area is units squared. It does save us a lot of geometry, I promise. But if you want to like challenge yourself, you can go ahead and figure that out. That would be my H. This could be my base. But careful, you would have to solve for who's across from the 72. Ouch, solve for C. Then you could go ahead and figure out what that angle is that you would need over here, which would be the same thing as 180 minus C. If you want to do the geometry, it's there. But I would advise you just forget all that stuff and say, hey, there's a cool formula. It's called Heron's formula. Maybe I'm just going to use that instead. This brings us to the end of 6.1, the end of 6.2. I am pausing the screen for just a moment to go look at maybe definitely one, maybe 2 homework problems. Those of you guys that have started homework, section 6.1, the one that's due today, where now this is interesting. South 41 west would be a little bit tricky for some of you guys to think about in the sense of compass. I have my north, my south, my east. We live in the west. I'm talking about south to west. I'm talking about starting in the south and going towards the west. 41 degrees. However, they have also kind of labeled things very nicely for me in the sense that there's the south measuring the 41 degrees to the west as well. From a tree, x equals 140, and they label that, oh, there we go. Oh, right here. 140 is that guy. And they tell me a few other bearings, but they also label the picture for me as well. Bearings are just a way of using the compass to kind of measure. Instead of talking about like from the x-axis, you can say from north, south, east, or west. What they're asking you to find is from the gazebo to the dock. This is my unknown. I'm going to call him y just because they already used x for something else. Now the really nice thing is if you guys notice, I could go ahead and, just based on the picture, do 74 minus 28, which would be 46. Has anybody already done that calculation? I believe that's 46. 60, 74.
Yeah.
I have angle, I have side, which is 140 based on what they gave me up above, and I just need one more piece of information. How am I going to figure that out? They gave me 41 degrees right here. What I really want is this angle measure right here. Once I have that, I can have angle, side, angle, and I can go ahead and use my law of sines. So where I'm headed is I'm really trying to figure out y over sine of 46 is equal to 140 over sine of the big fat question mark. If I have that little question mark, the doors are open, the path is paved for me to go ahead and solve. If we were to go ahead and look at the step-by-step, because I wasn't meaning for you guys to do this completely alone, they do give us a few hints. For instance, they say something like BE, straight down, north-south, is parallel to CD, north-south. As a result, I can see this CB as a transversal. And if I can see that as a transversal, then all of a sudden I can say that, right up here, 74 degrees, once again, these are parallel from geometry. I can say that 74 plus, what's over here, 41, plus question mark. Same side interior angles are supplementary. I know that they're going to add up to 180. So your problem is going to go ahead and lead you to doing 180 minus 74 minus 41 to get your question mark. And once you get your question mark, you will be primed and ready to go to solve with law of sines. So it used a property of parallel lines from geometry. Go, Mr. Grapp. Number 11, the Leaning Tower of Pisa in Italy. Leans because it was built on unstable soil. Interesting. The tower is approximately 58 point, and they label some stuff for me, right? The top of the tower leans about 5.45 meters off center. Now, once again, they do give you very specific information as to what they want you to be looking at. For instance, first they say, find the angle alpha of the tower. It's like, wait, you should be able to figure this out. And it's like, oh, yeah, I guess I can. Because if I want to find alpha, I just need to think about this right triangle right here. A right triangle where I have a side and a hypotenuse. So all of a sudden, I can think of something like, well, side squared plus side squared equals hypotenuse squared. And with a pretty simple subtraction and square root, I should be able to end at what I need as far as alpha. That's just Pythagorean theorem, everybody. But I'm guessing, I'm hoping that's not the one that we found most hard. Instead, possibly we might have gotten a little bit stuck when it started asking us weirder things, like about the oblique triangle, when it says write beta as a, wait, I want to get beta by itself? Well, we are in the law of sines formula. So if I want to somehow write beta, I have to think about what I know about law of sines. The law of sines says beta is going to equal sine inverse. And if I was to take my little, like, okay, sine of beta all over, what's opposite beta? Opposite beta is D equals. Now I need to know somebody else. Oh, I know 58.36 and I know theta, or at least theta's in my picture. So I could have gone ahead and rearranged that whole thing and done a sine inverse, and I would have sine inverse of D times sine of theta all over 58.36. I know you can't plug in things, but guys, if you read your problem, it says get it as a function of, yes, I have a D, and yes, I have a theta. All that was just me using law of sines and getting beta by itself, and I'm pretty sure we have accomplished what they asked us to. But then part C says, let's go one step further and put the two pieces of information together. And they say, now get D by itself. And getting D by itself, I actually have D right here. And they want it in terms of theta. I would probably flip around a few of these things, multiplying up by D. Actually, I kind of have it right here. If I just take my sign back and then move everything else, I will go ahead and have the following. Sine of beta is going to have that 58.36 come on over and be multiplied. If I just rearrange stuff, once again, getting D by itself this time instead. The only bummer is it doesn't want theta. The only bummer is it only wants theta. So the question is, who is beta and how can I solve for him so that he's not in there? If you guys notice, once again, the wording was just in terms of theta, so there must be a way to get rid of beta itself. And if you look over here, what we actually have is back to Andy, what he said earlier. 3 angles in a triangle add up to 180. I have theta. I have beta. And I have, ready, 90 degrees plus alpha. That's that third angle. So if I wanted to get rid of that beta, I totally could. And I could say beta is equal to 180 minus 90. That's just going to be 90 degrees. So I'm going to have 90 minus alpha minus theta. You already found what that alpha is. I can go ahead and come on down and plug him in. And then if you put that whole thing together and plug them in the beta spot, you will have the answer that you want. If you guys noticed, I did go ahead and flip back and forth so that those pictures are definitely visible in some of those frames. If you guys come back and check out the video and where I was talking about it, you can double check your answers and make sure you're good to go. They all should be there. So you take that formula, put it in your y equals, and go from there. I did say I wanted to start section 6.3, so in the last 4 minutes of class, P.S. once again, I did split back and forth to WebAssign quite a few times. If nothing else, I did it just one more time. You guys should be able to access that in the video if you want to, if you need to. Here we go, 6.3, just to start it. You guys are doing great. Finish line. Here we go. Last few minutes of the game, give it all you got. Who remembers what that little supervillain with the piranha gun said? A vector is a line segment that has both somebody knows it. Direction and
Oh yeah.
you remember the oh yeah. Magnitude. Like an earthquake. You live in California, you should be able to remember that one. Direction and magnitude. Oh yeah. Piranha gun. Oh yeah. Okay, we're done. A line segment that has both direction and magnitude. Used to represent things like force and velocity. P.S. Your book and WebAssign will show things like bold letters. However, for us, in order to show vectors properly, handwritten vectors, you are not doing bold. Instead, you are putting the arrow. Some people put a double-sided arrow. That reminds me too much of geometry. I like a little one-sided arrow to make it look cool. A vector V. So whenever you see bold and WebAssign on paper as you're showing your work, you're putting an arrow above it. You do not make your letters bold.
How do we do it in one?
I'm not sure if WebAssign has you actually write it down. I was thinking more handwriting, but you will see them using bold letters. But if they do have you writing it down, I believe in CalcPad that they do have bold letters that you can use if you need to. But a vector says, hey, I have a beginning. And technically, what's weird and what's not like geometry is it also has an ending. That arrow does not mean going on forever. That arrow means in this direction. So a vector does have an actual length. That length is going to be known as magnitude, which we'll talk more about next time for sure. It is going to be at some sort of angle. And as soon as we start talking about like, hey, it has a length, and hey, it has an angle, and hey, they can rotate, all of a sudden we can bring in all of our trigonometry skills by saying, couldn't we break this down into its horizontal and vertical components? And couldn't we start talking about not just the vector itself, but also the vector's horizontal pieces and vertical pieces, which actually makes vector math way, way, way easier. So even though little vector guy was right, that we could talk about magnitude and direction, direction being like a theta, magnitude being like a radius or a hypotenuse, if you want to think about it that way. It's actually much, 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 much easier to think about it as a horizontal and vertical displacement. We're going to put all those pieces together next time with things like right triangle trigonometry. All right, cool kids, I'll see you later. Let me stop my recording and get it. Hold on, let me stop my recording.